Hello, Larry BL again, and we're going to continue. This should be one of the final episodes of the solenoid. This is where I've actually taken one apart so we can look at how the solenoid operates, and from here we will transition into the key switch, because believe it or not, one of the main functions of the key switch is to operate solenoid. So what I've got here is I've got one of the single terminal solenoids, and what I have here is another single terminal solenoid that really wouldn't do us any good because it was broken at one point. So, but it does a very good job of me being able to drill the rivets out and show you how one works. So we will start at the base of the solenoid. Okay, the base of the solenoid, basically the purpose of the base of the solenoid is to ground the coil. This is the little electromagnetic coil we call the field coil that's inside, and it's nothing more than an electromagnet. And one terminal of the electromagnet you see is soldered to the metal plate, and then I've cut the wire on the other side of the coil, which actually connected to the terminal here. So on this coil, this terminal would go to the positive of the battery. The plate would be grounded. It has a spring, and the only purpose of that spring is the same purpose as the spring in the bottom of your flashlight. When you put the batteries in the spring, in the flashlight, the spring connects the bottom of the battery to the flashlight terminal. Well, the only purpose of that spring is when the coil is in place, it grounds the one terminal of the coil, and the other terminal is connected to here. So when a positive current is applied, this becomes an electromagnet. With that, there's a metal plunger that has a hole about 1/4 inch down in one side. The metal plunger fits inside the electromagnet. So now if a current's applied, it would push that plunger up. The next part of the coil is basically a protection, a little metal protector that fits over top of the coil. And then we have a little plastic plunger, but it is connected to a copper bus bar. So what happens is this little copper bus bar and plunger is inserted into the coil on top of the protector and into the plunger that's into the coil. Then there's a little spring that is inserted on top of that plastic plunger, and we're going to omit him for right now because it's getting a little awkward. So the last part of this guy, so what happens here now is if we apply current to that electromagnet, it's going to push this whole assembly up, including this copper bus bar. Now if you notice on this bus bar, and I'm trying to get it to focus a little bit better, you notice how burnt the end terminals are. Well, this is one common problem of your solenoid. When this bus bar, every time this thing engages, it arcs, and this is where your solenoid can burn out. Because what happens now is on your top two terminals, your heavy duty terminals, we'll go ahead and pull this one off, and I had it off just a minute ago. So I've just pulled this out, and if you notice, it just has a striking plate that rides on top here. So now when this unit is put together, when the unit's put together, bear with me, that copper bus bar is shoved up, shorts out the left and the right large terminals, allowing current to pass through. So basically what we're saying, it takes a little current to make an electromagnet to pass a large current using the big contactors and the copper bus bar. Okay. Real quick on an explanation here now. we have a large current going across the top of the bus bar. We have a small current going to the terminal. Sometimes people say, well, all I get's a clicking sound. Here's what can happen. Let's say your battery is rated at 250 cranking amps, but it's got about 3 years on it, so it's really only putting out 100 amps. Your starter requires, let's say, 100 amps. Okay, fine. When you engage your starter, you click, there's 100 amps, which allows it to engage this little field coil, which only takes a couple amps, but now you're drawing the full 100 amps across the top bus bar to the starter, so now you no longer have any current for your field coil, which collapses, so the magnet drops, bus bar disconnects. Now all of a sudden you have current again at your field coil, engages the bus bar, 100 amps to the starter, not enough for the field coil, and it does this in rapid succession, so you get a fast clicking sound. So if you do not have enough amperage, either because of a bad connection or a weak battery, the clicking sound you hear in the starter is the heavy current eating up all your current and not leaving enough for the field coil. That's my explanation, and I'm sticking to it. Thank you all for watching. And next episode we'll talk about the key switch and its functions. Thank you.